Uh, all right, so welcome everybody. I'm here on behalf of the University of Pécs, the Faculty of Engineering and Information Technologies. I work now full-time at the university as a web developer, but I'm part of a research group. My research is about file systems, but I will talk about that later. Most of what I will talk about is connected about space, but there will be projects and other stuff that our student group, CosMIK, which is part of the University Special College, made during the 2 years of our work together. So just before getting into anything, a few things that I want to tell you just to share the same knowledge. What you see on the pictures, the left one, is a CanSat. A CanSat is basically a can, as you would imagine. And it's a small satellite. It's not actually a satellite that goes into space. It's more like an educational type of satellite. Because it's small, it's usually used for atmospheric testing. What you can see on the right side is CanSat, the first Hungarian satellite which went to space, developed by BME around 2012, as I can remember. It's a 10 times 10 times 10 times 10 centimeter cube, which is a 1 unit CubeSat. Just because I will refer in the future as CanSats and CubeSats, so you know what I'm talking about. Okay, so what is CosMIK? CosMIK basically started as a friend group. We started studying together, and then we wanted to do projects together, and that's how we went to University Special College, where they said that, all right, let's do something. It was in 2024 when we started our first project, Mimike-I. Mimike is the mascot of the Faculty of Engineering and IT. This is why we named our CubeSat after him. So Mimike-I was a successful proof of concept that we could develop something like that. It never actually materialized in a physical form, but there were codes that we wrote for it, and there were hardware designs, PCBs, which we wanted to order, but at the time we couldn't do that. Simultaneously with that, we launched CanSatLab, which is not a club, but an education for high school students, where they came to the university, and we told them what they should, or how they could build a CanSat for a competition, CanSat Hungary, which we went with parallel. Yeah, so they came to us weekly for like 10 plus minus 1 weeks, where we taught them a lot of things about electronics and programming. This is a photo of them where they used some breadboard stuff to communicate with their computers, measured room temperature and humidity. So this is a map that where you can find CanSat labs in Hungary. Here you can see that there are not too many. Mostly they are at Budapest, but here we are on the map too. What you can see on the picture is a development board for this for the CanSat lab, which we are going to use to teach the high school students for electronics and programming. You can see not everything is soldered on the board yet, but you can see that here's a place for a radio, and here is the place for the MCU, which is an ESP. I have one with me, which I will give you, and you can look at it. Please don't take out of the foil, because we still want to use it. Yeah. But it's a good thing that now we can afford these kind of things, because it's really a more hands-on experience for them to learn with this kind of stuff than just simply on breadboard wiring together stuff. All right. So after Mimike-I, we wanted to do Mimike-II, obviously, to continue the project. And this is when we met with Stratospace Corporation, which is a Hungarian corporation. They have a balloon which goes up to 30 kilometers in the atmosphere. So it was a good opportunity that we could test our knowledge and experience that if we could build something like that. On the picture, you can see our usual work environment, which involves a lot of tinkering and beers. So yeah, this is how we usually work. It's not so sophisticated and clean when you are just software engineering, because then you don't have to fabricate a lot of stuff on the fly. All right, this is a more this is a development board used now. As you can see, that here is a microcontroller, which is an Atcham D21G18, which doesn't have to say to you anything if you are not really into embedded software engineering. But it's quite a good microcontroller. This is what we used in most of our projects. And we have radios and GPS, etc. A lot of stuff that we can use for measurements, for location determination, and for storage. We started this project on 2025 May, and it ended 2025 October, around October. But I will get to there. The goal was basically, now that we have opportunity to fly up, to validate that we can build stuff like this. So basically, sensor logging, storing the data, and retrieving it back to the ground. But we wanted a real-time radio downlink during the flight. We planned on using LoRa, a long-range radio module for that. It is an interesting challenge, because if you need to build a CanSat and a CubeSat, there are strict mass and volume limits that you have to keep your stuff inside if you want to fly up. Yeah. So basically, we managed to create the boards. It was a 4-board CanSat unit, which I have with me, and I will give it to you. So you don't have to be an expert in embedded stuff to see that it's not flight ready. That's because eventually we ran out of time, because apparently 6 months from building a CanSat from zero for 5 or 6 people, it's not possible. Which I was born to, but I was like, nah, we can do that. So it's 4 PCBs. I don't know if all 4 is on that. There is a central unit, which is orchestrating the measurement units and the radio and SD card, etc. It's the OBC, onboard computer. It's an interesting thing that space technologies have completely different acronyms for the same stuff as embedded things. So what you call on an embedded system an MCU, you call it an OBC. But it's like slightly different thing. All right. So the system sort of worked parts at a time, but it was like that it was the morning around 2 a.m. On the day of the lunch when we were like, it won't work. We're just not it's just not possible to finish it. But apart from that, we said that it's a success because as an engineering demo, it quite worked as a first revision. Yeah, that's another picture for it. OK, yeah, I talked about that. So this is where I would mention ZINF, which is I don't know if there's anyone here who knows about it. Yeah, it's completely OK, because it's what I made. So it's basically made only because I'm lazy. And when I had to implement a FAT32 file system for the CanSat, I was like, I won't read the documentation. There's no way that I'm reading all that stuff. And I said that I could do better. Yeah, that was a 6-month, 6-month long project because of just for the first revision. Since that, it's now at the 4th iteration, but now it's completely capable of storing data securely, and it's usable for non-technical people too. Yeah, it's using grade 1 mirroring, CRC32 integrity checks, and it's really important that it's completely deterministic. Yeah. OK. Another thing, in January, we were lucky enough to go to the 8th Winter Satellite Workshop in Finland, where we met with BME. It's interesting because they said that, hello, we have a CanSat, a CubeSat framework, and we were like searching for a CubeSat framework because we have a scientific payload what we wanted to build, but we just couldn't manage to fit in building a CubeSat too. So like the main part. But they were searching for scientific payloads. We were searching for a CubeSat, so we found each other. And this is how we started the project Palantir, which is free space optical communication. It's not that complicated as it sounds. It's basically Morsing with light throughout space. So it's quite the same as how we use optical communication through wires. It just goes through plain air. The difficult part is not the communication, it's the aiming to get the satellite. What we started to create is a half-duplex communication. So we can talk up to the satellite, and it can talk down, send data down, but only one at a time. Yeah, and now we are doing this project. We are working with BME. And we hope that we will be able to finish this project with them. So, and the finish for us is in December, because in December we will do our diplomas. Yeah. Yeah, but now because we are attending TDK again, it's quite frozen because there's not too many of us. We are like 5 or 6 people in the CosMIK group, so we just can't handle this amount of work. But I put this picture in because of the DevOps presentation. That's our development infrastructure, which is don't let them trick you. They are not used for PCs. They are just there for their case, for grounding the electronic stuff. Yeah. Other projects that not really connected to space. Our group went to TDK conference, where we received the first and the third place in computer science engineering category. And actually, there is 3 of us from this picture right here, right now. Please raise your hands, you too. They are quite shy at these events, but but you can ask questions from them too later on. So other side project is a digital hourglass, which is the diploma project for Barney back there, and an intelligent plant waterer, which is a TDK project. But the two people who are doing it, they are not here now. We were lucky enough to be at different events where we could reach out for not just other university students, but high school students, like Researchers' Night, Science Festival, and Orientation Day. We are usually there as part of the Juhászínű Special College, so you can find us there. Okay, but as you could realize by now, that it's not that easy to do these kind of projects at the university because there are difficulties because we are just students. So we don't have professors, or not that they are not, they couldn't help us that much. The problem basically is that we are low on leadership, but that's a problem for all university projects, that usually there are a lot of enthusiastic people who want to do something, but then there's no control and help from higher level layers who could help and push them forward. So there's no exact project management other than us trying to, hey, could you do that for tomorrow? So that's not really a good thing. And another problem is bureaucratic friction, which is a fancy word by Claude, but basically it's that it's really hard to ask for things that like, we should order, I don't know, a microcontroller. All right, then search that person with that, and write that there, and then 2 months later, maybe it will arrive what you asked, but maybe not that. Exactly. So, and when we are talking about 6-digit long microcontrollers, if a digit is wrong, it's not good for us anymore. Yeah. So these are the negative sides. So what's planned for our future? This is a picture. There was the Harman Hackathon at Pollack Expo last week, where we got the 2nd place for our robot car, which one of the robot cars is actually here. This robot car, which I will give around. It might fall apart, but don't be afraid of that. It already burned down. So yes, I don't remember that. How did you name this? You neither, all right? Yeah, but the point is that we are attending other educational competitions too, not just space-related things. So our future will be like that. We will attend the H-Space conference at the BMA in May, where we will present the Palantir project as it is now. We will attend the TDK this spring and winter this year. We will want to finish, I don't know if I maybe forgot to name it, but the light transmission protocol for the Palantir project named is Ilona. So we will want to finish that, and we will want to scale up the team, more about in leadership side, so we could work more efficiently. Yes. So for summary, after all the difficulties and challenges, not really in space technology, but in project management, I can say that that university students are fully capable of developing a big project like this with a good leadership. Yeah, and I think that's all for now.